Well, hello friends. Welcome back to browser hacking. Today we are going to work on iframe. So we don't have any frame support yet in our browser, and there are various abstractions missing to support this. But today we're just gonna sort of start from a very simple test document and then work our way through and see how far we can get. So we'll be starting with making a little test page. I guess I'll just put it here for now, HTML. And, let's enjoy the support for crappy markup by not putting HTML element. So I guess we'll call this the F HTML. So I will be the main page, and this will be our test thingy. And then I guess we could have like an intrinsic width and height, 200, something like that. This page has an iframe in it. Cool, huh? Really abusing that, those tags and stuff. And this text is after the iframe. Okay, so that, and then we'll also have a page inside of the frame. So this is inside the frame. Maybe we'll even put an image here. So I guess we have 90s PNG. Is that, if I recall correctly, what it's called? Oh shit, wait, I wanted to open I. Also, that was not the right path. So the path was it 90s BG? Yes, that's the one. So I think making it scrollable, that's maybe we're not going to go that far today, but we'll have something to look forward to. So yeah, basically this. So let's see how this looks inside of our browser right now if we try to open this. We have basically no recognition of iframe tags. So the rest of the page comes out all right. And if we look here, we can see that the DOM is looking pretty good. Thanks to the new HTML parser, we actually do the right thing with this silly looking markup. Okay, so let's go ahead and define some classes. So for this, we will need, in the DOM, we're going to need we'll need an iframe element. So we'll just copy input element to start with. And then in the layout code, we will need layout, which is called frame, I guess. Should we call it layout iframe? Well, if we do frame set frames later, they'll basically be very similar. So maybe we just call it layout frame. I think we can probably do them in the same class. Well, let's not overthink it. And then let's edit the CMake file. DOM HTML iframe element setup. Oh, and the layout node, of course. Layout, iframe, CPP. Okay, so I think that should be what we need for them as far as adding new classes goes. So let's go and flush some of these out. So iframe element, obviously we have to change some stuff here. So we're just going to do a search and replace. Okay. And maybe we'll put that it was made this year. Okay. And then in the iframe element CPP, same search and replace again. All right. And of course, this is going to be very different from the input element because the input element basically is a host to a native widget. So like a GUI button or a GUI text box or something like that. But the frame is going to be the host to a libweb frame, basically. And currently we do have a frame class, and the web page is all in one frame right now. But I added this originally knowing that we would want to do frames and iframes eventually, so it is part of a tree. So it's inherits from the tree node abstraction, and it's able to have children and parents and so on, or just one parent per frame. But, anyway, so I think to make that work, we're going to say that an iframe element has a it points to a frame optionally, and let's see, should we call it something like an inner frame or something like that? Because like this iframe element itself is in a frame, which is the frame of the document that has the iframe in it. But then this here, this like the hosted frame or the child frame, inner frame, hosted frame. Hosted frame is pretty good. Let's call it that. Okay. And let's have a way to access that. So frame, hosted frame. And let's offer a const variant for good measure. Okay. And I guess, I don't know, we'll see how we work this whole thing out. But basically, when we create a layout node for this guy, I think what we're going to do is we are just going to create a layout iframe like this, lab, layout iframe. Oh wait, no, it was called layout frame, right? Should we give it style? Maybe we should. Wait, this is the style of the parent, not the style that we should have. Okay, hold on while I remember how all of this works. Style. So we have to resolve our style like this. Clickety clack. And then we can pass that to that function. Okay. And and layout frame, we need to change from layout widget to layout frame. Okay, and we'll say is frame is true, which we will get from, let's see, layout node. So layout node is the base class of all layout objects in the layout tree, and we just use these virtuals to distinguish who is what. So we'll have an is frame that we can use to check if something is a layout frame. Or I can make that private. So layout frame is going to be a replaced element, and replaced just means that it has behaviors that are not governed by CSS. So typical replaced elements are IMG, canvas, input, and frame, because they have these behaviors that are not just following the box model and CSS stuff. Anyway, here we don't need to stash the widget. I think we'll keep them. We'll need to keep the frame with the DOM. So for the layout widget, which is the input element stuff, so like if you have a button, we keep the GUI widget with the layout node. But in the case of an iframe, we have to keep the frame pointer on the DOM node, because if you set an iframe to display none, I'm not sure what's supposed to happen. I feel like maybe you should still be able to reach into it. I'm not sure. We'll figure all these things out as we go with this stuff. Maybe you already know the answer, but I don't know the answer. Okay, that's pretty nice and tidy. Let's clean that up a little bit, and then we'll go in layout frame CPP. Okay, this can be simplified. Okay. Flip and flip. Okay, so now we have our bare bones class here, and when we're constructing a layout frame, we're going to be getting style properties. So we should just pass that along to our parent class. There we go. And the intrinsic width, it's not quite this simple. So maybe we'll take care of that in layout instead. For now, let's just grab the intrinsic width by querying the properties on our element. Do we not know what our element is? Okay, well, so here's something that I like to do. So since we know that the element corresponding to the layout node, the layout frame node, is going to be, at the moment, we know for sure that it's going to be HTML iframe element. So we can just go ahead and add a casting helper for that. Although, at the same time, if we want to use this for regular frames in the future, maybe we should use the nearest ancestor class, which would be HTML element. Wait, what am I doing? No, not const. Static cast HTML element. That already gives us a node. Or rather, it gives us an element, but we can cast it a little bit more. Not that HTML element has anything particularly interesting. I like to use tighter types whenever possible. Maybe we should call it node, shadow the parent. Okay, and then we also need virtual void layout. Okay, so the intrinsic width of the layout frame is going to be the attribute width to int let's be a little hackish here. It's okay. We're just gonna do that and fix me do more proper error checking, etc. Okay, and then we can just delegate to replace layout system. Yes. So let's see how this fares if we just build this. Oh. Layout iframe. I've been a little bit sick today. I don't know really what's wrong with me, but I just had to sleep for an hour and a half in the middle of the day, just totally knocked out, stomach hurting and stuff, but it's starting to get back to normal, so that's good. It's good to do a little programming then. It's always good to do a little bit of programming. So we are passing the style there. Yeah, that looks good. Although, what does layout replace to? It takes it like that. We should do the same. Changing all those little things that don't really matter that much right now for some reason. Move. I mean, I guess it's nice to use move semantics, but okay. So, did we achieve anything here at all? No, we didn't, because we forgot to hook this up in the element factory. This is how the HTML parser produces C++ objects for the incoming tags. So when it gives us an iframe tag, then we need to be smart and produce an HTML iframe element. Just like that. Oh. Well, I don't know why I removed render, because we're definitely going to need a custom render function here. It's just that right now it won't do anything, but it's going to have to do stuff. Okay, so now we're starting to see something going on. We can look at our layout tree here. So what do we see? We have a body element, and then a P block, another P block, and here is a layout frame inside of this P block. This page has an iframe in it. Cool, huh? Oh yeah, right, the frame comes after that, so it should be like this. So we can't actually see the box around the frame, although if we bring up the inspector, we could maybe, okay, seems like it doesn't have that much of an interesting thing. It's right here at these coordinates, size 300 by 200, so it is looking good. I don't know why this thing here doesn't paint it correctly, or supposed to paint a frame around it, but it's a little bit unreliable, so probably don't have to worry too much about that. Alright. Oh, I wonder if it would work to put a border around it. Let's just try that border 1px solid black. No, that didn't quite work, but why not though? So the border at least applied to layout frame, but Oh shit, wait, it's because we're not calling the base class. Yeah, then we're not gonna paint. Don't have to get too carried away with trying to fix border and stuff like that, because border is not super important. The important part is like loading up a separate document, right? So that's that, and let me just slap a border on this boy right quick. Okay, that's better. Yeah, so we know that the border is good. Maybe we'll put that one in a more permanent way. Style border 1px solid magenta. Or wait, no, that's the inspector color. 444. Okay, so what are we gonna do next? I guess the next big thing now is to actually handle the source attribute. So we need to do something when we get that source attribute coming in. So we'll hook parse attribute. Which looks like this if I don't misrecall. So this function gets called whenever we set a new attribute on an element. So this will be where we learn that there's a source attribute. Of course, the first thing we'll do is we'll just call to base, give him a chance to pick up stuff like the class attribute, which is handled in the element override of parse attribute. So it's important to call to base with this one. I had a bug yesterday that was image elements were not calling to base, and then you couldn't style an image element with a class selector, and that was a bit confusing. But then I figured out that it was just missing this. Okay, so if name is HTML attribute names source, then so what do we do now? Now we have to load a frickin' HTML file, or actually really whatever comes in. And all of the logic for loading like a document resource is currently in our page view class, which is the sort of the widget that you put into your GUI application. So if you want to use libweb, you put a web page view somewhere in your UI. And all of this loading logic and stuff is here. But we really want to share that logic for frames. But instead of like building out this new loader thingy for frames, let's just start with proof of concept. So we will say loading iframe document from value, okay. And then URL is document complete URL from value. If URL is not valid, actually no, I'm not, because the URL is not valid. Yeah, and then we'll bail. But if everything is good, then resource, or yeah, let's just grab the resource loader here. So resource, where is it? Loader, resource loader. I already forgot that I moved it. So maybe we should put this in a separate function actually, because it's gonna grow a bit. So load source, something like that. We'll just say load source. Okay, here we are. So resource loader, load. Let's do a synchronous load just because it simplifies what we want to do right now. Obviously, we should do asynchronous loads throughout the engine, but at the moment we're kind of sort of using synchronous loads to make things a little bit easier for ourselves while we're building all this stuff up. And while the resource loader itself is not like super capable yet. So let's see. So a synchronous load here would just require, or we would get data. This is if it succeeds, data and headers. So, oops, I put those in the wrong way. And then if it fails, error. Okay, so why does this look so goofy? Oh, because of that. So if it fails, let's say debug. Iframe fail to load. Error. Okay, and maybe we don't care about the headers super much right now, but we care about the data. So HTML source is string copy of data, and then because data is a byte buffer, so then we'll just throw it into the parser, I guess. Parser, HTML document parser. Yeah, so this will be very hackish while we're just messing with it. Document parser, HTML source, and the encoding. Let's just say UTF-8 right now. It's probably in the header somewhere, or it might be in the headers. Anyway. Parser run with the URL, and because we have to tell the parser what's the URL of the document that he's parsing. It's used in some place for something. I forget. And then now presumably we have a document, so we can just say, I guess after we parsed it, we can actually construct a frame to put inside of it. Or we could just construct a frame no matter what. So we could say hosted frame is frame create. And oh, how does that work? Frame currently must have a page view. Well, what do you do with the page view? That's because people are asking you for the page view to grab a palette and stuff like that, to trigger a reload. Yeah, so this stuff is gonna have to be a bit different, because if say that you're a script inside of an iframe and then you trigger like a window.reload, then you should only reload the iframe at that point, because you're calling the window object that you're calling reload on is the window object inside of the iframe. But there's a whole bunch of stuff like that we're going to have to deal with. And scripting is not going to work at all right now, because the JavaScript engine is instantiated per document. So we'll have two completely separate JavaScript interpreters in the host document and in the hosted document. So that's also something that we're going to need to change dramatically, and maybe have like a single I was thinking we could have a single interpreter, but I'm not sure exactly how we're going to make that work. We're probably going to want to have a single JavaScript heap at least, with multiple global objects floating around. And currently, there's a one-to-one mapping between interpreter and global object, and that's obviously not gonna be sustainable. So many things we have to change. Anyway, let's just create a frame. So we'll just grab the document frame page view very, very lazily like this. Fix me. OMG, this is obviously not sustainable. The right way to do this. Right. But that means that we should have a hosted frame at this point. So we can call setDocument on him. And we'll give him the parser document. Okay. And then after we do this, the hosted frame now has this DOM, and then we will dump the frackin' hosted frames document like that. I think that'll work. Web dump. Oh man, it's going to be so interesting to see if this works. Ooh, very crash. Alright. Why are you mad at me, bro? Parse error. Sure, and then we have a null bref somewhere. In create element. Huh. Create element of all places. So we are hold on, what is this? This is the iframe page view load, create document from MIME type. Iframe element constructor is messing up. Oh shit. This thing here, right, it's not we can't do this when we construct because the document is still frameless when we construct this element. So when the parser creates a DOM element, such as this iframe element right here, the document is just this temporary thing that the parser is building up, right? So it's not yet connected to any frame or any page view or anything like that. Excuse me. So for that reason, we actually have to delay this a little bit. When do we want to do this? I guess we can't actually get the page view, so maybe what if we just don't have a page view pointer and we allow you to create a frame like that, and then it becomes the right way to do it. But create, and this will be like a subframe. And oh, I guess actually what we should do is we should really say like who the parent frame is. But for now, we can just do like this. New frame, who this. Okay, so not such a big deal. There we go. No matching function for create. What about create subframe? That seems to work a bit better. Failed to load, no such file or directory. Yeah, that's my bad. This URL here is obviously not correct. Home anon HTML. There we go. The hosted frame now has this DOM. Okay, so we have successfully loaded an HTML file, parsed it, turned it into this DOM. That's already pretty cool. So what comes next? Let's see. So how do we do this? I guess one thing is that we will say set needs, no, not a style update. Let's go to the layout frame, and then when we do a layout, he already has a width and height. And what we should really do is communicate this information to our hosted frame, which, so that's what did setrect is for. So whenever the layout system sets the specific rectangular dimensions of a box, you get did setrect is called, and then you can actually use that for something. So you can, in our case, what we want to do is we want to go to the node, and actually, this is the part where we wanted it to be a layout, an iframe element. So we're going to take that little shortcut right now, and then we'll have to deal with this when we do regular frames. Because what we want to do here is we want to say node hosted frame. First off, we can assert that we have a hosted frame, and then set, wait, how do we need to set the size of it. Set size? How? Don't we have a way to set frame size? They have a size. They have a set size. Is this a const thing? Oh, because node is const. Well, not anymore, brother. Boom. And boom. You don't seem happy. I guess because this is also only const. Probably because this is also only const. Okay, I think I had some illusion at some point that the layout tree would have const pointers into the DOM, but that illusion is falling apart. So let's just deal with it. Is this going to be painful? This might be painful if we assume constness everywhere. So far, so good. Maybe just lay out node CPP. Yeah, what if you don't take a const node? What if you just take a regular node, bro? What if you just take a regular node, and then, you take a regular node, and you take a regular node, and you take a regular node, and did I mention you take a regular node? Layout block, node. All right, come on now, libweb. No time for this const nonsense. Is this const? Oh, come on, man. Okay, this is spiraling a little bit, so let's backtrack. Let's backtrack and const cast because I don't want to muddy everything up right now. Layout block. You absolute legend. with style. Wait, is there such a thing as git checkout -p? I'm gonna try it. Please exist. I hope this does what I think it does. So I should be able to. Yes, it does what I think it does. That's so cool. So let's keep that. We'll not touch those. Not touch those. Okay. So git checkout -p allows you to select which things you want to reset to be, or which changes you want to get rid of, basically. That's awesome. I did not know that existed, and now I do. And now you do too. So everybody's happy. I figured we could just go and make this a nasty const cast right here, and with the ambition of getting rid of constness on layout tree DOM pointers. So let's check out layout node CPP. Okay. Well, that was a silly sidetrack. So in layout frame, what we wanted to do was to just call set size with the size that we've got here. So you can actually even get the width, graphics size, because it's the layout tree in the libweb has floating point size, and the frame has integer size, vinegar size. So we just have to convert it. Maybe that should be a helper on float size. I don't know. Okay, so we're gonna have to open this a bit more awesomely, like that. So now we loaded the DOM, and hopefully we set the size of the hosted frame, but then nothing more happens, of course. So now, how do we actually render the content of the frame? So basically, the way rendering works in the engine is that we just very simply traverse the layout tree from back to front. Now, this is not how it's going to be as the engine matures. We're going to have to add stacking contexts and stuff like that, but right now it's just a very simple top to bottom, back to front render of each node as we encounter it. So if we bring up home and on I, and we look at the layout tree, and we can see the tree here. And the way we paint is we just start here at the root and then recurse into its children and paint them one at a time. So no attempts to avoid overdraw, anything like that, and absolutely no respect for z-index. So regardless, when we get to the point where we want to draw this thing, which is at these coordinates in the page and with this size, what we should do is delegate to the layout tree inside of the iframe. So home and on. Right, let me just fix this so that we'll do this. That way we don't have to keep tweaking the file name. So here, I guess when we do the layout, we also want to do a layout inside of the frame. So when the rect changes, then we will do a hosted frame document layout. Ooh, I like it. And then when we render, oh man, how the heck is this going to work? So we have our rendering context. I'm thinking we will do a context painter save and restore. Just make sure that whatever happens to the painter while we're in the frame context, if we restore it when we come back. Maybe we should even make a custom painter, I don't know. So, rendering context. Yes. Do we need to make a custom rendering context for this? I suppose the viewport rect is different. Viewport rect. Wait, how do you... Oh, set viewport rect. I was wondering, like, how does it know what the viewport rect is? But it's a setter, so that's how. So we could keep this rendering context and then change the viewport rect temporarily. Old viewport rect is context viewport rect. Set viewport rect, old viewport rect. Okay, because then we can say context set viewport rect, and then we'll just give it the hosted frame rect. Size. So an empty rect with that size, or a rect at 0, 0 with that size. I think that'll do it. Okay, and then how do we paint this thing? We will just have to call node hosted frame document layout node. Render into context, I guess. Oh, as you can see, I haven't I haven't thought this through, so we're just going. We're just exploring this, figuring out as we go. But I guess if you've seen this channel before, then you know that's what we normally do. So nothing too weird. Although this is stretching my brain a bit. Just modeling how the heck this works. Okay, so this is actually the content that's inside the frame. It's at a totally bogus offset, but we're definitely drawing it. That's so cool. I guess we should, how do we do this? We should translate the painter so that it draws into the location that we have the frame at. So context painter translate, and then we'll also have to clip it so that we clip to the, maybe let's do that first. So add clip rect, node hosted frame rect, no? Okay, well, hold on, let's try just clipping to our own size, actually. Float rect. How do we enclosing int rect from our rect? That's how you do that. Yes, and then we need to translate the painter. Now that we've clipped it, we can translate it to our rect x, our rect y. Maybe even like that. Check it out. Dude, that's so freaking cool. I love it. It's an iframe. We have an iframe in libweb. That's so freaking cool. Now, obviously, it's very limited. Like, you can't scroll it, and you can't script it. But it is an iframe. We have an iframe in our document. Very, very cool. So let's go ahead and just fix up this little demo right quick. So we'll put this one here, iframe HTML, iframe subframe HTML, and then in iframe HTML we will say iframe subframe, and then we will link to this thing because I'm so happy with it that I want it to be part of our amazing manual test suite. Poof. Ah, we messed it up. But wait, how did we mess it up? The hosted frame now has this stuff. Oh, because of the image offset. The relative path to the image is probably wrong. Yes. Just like that. Of course. Oh, why are we crashing, bro? Okay, so we have a resource did load on an image element. Wonder if we will crash again. Yes, we do. Okay, so it's reproducible. That's good. So where are we here? Iframe element, load source. So look at this stack, by the way. You can see here that we are loading the outer page, and then we're in the HTML parser, parsing generic raw text element, and inserting an HTML element, blah, blah, blah. And so we're inserting the iframe, which causes it to do a synchronous load, which causes it to spin up another parser that calls load image. And we do set resource. But then in resource did load, why are you mad, bro? So we're reusing a cached resource for this. Okay. So the image that we're opening, it's the background image of the page that we're leaving, right? So if we go directly to iframe HTML, it works. But if we go to our test page where this is the background and then we switch to this page, then it crashes. So something goes wrong with that. And I wonder why. Let's take a look at HTML image element. Resource did load. So who here is a freed pointer? Now this, by the way, this pattern here, we fill freed, whenever memory is freed, we fill it with this byte pattern. So for that's how the kernel is able to give us this like little heuristic answer here that like, hey, this address looks like it may be uninitialized malloc memory. So actually I even lied, it's not recently freed, it's not yet initialized malloc memory. It's a good thing I read it out loud. So uninitialized malloc memory. Why are we looking at that? We are 203 bytes into the function, so let's just bring up the assembly. This is in browser, so applications, browser, and that was the address. So what's going on here? We are right after ensure decoder. Okay, so we're assigning to M image decoder. So let's see what's going on. So we're in the inner parser. This is the parser of the subframe document. It's inserting an image element. The image element calls load image during attribute parse, presumably. Parse attribute. If the attribute is source, we call load image, and then load image set resource load resource. Wait, hold on a minute. Set resource load image set resource resource did load. What is going on here? Load resource. This thing, because it's cached, we'll just reuse the cached version, which means that the call to set resource will directly call resource did load. Okay. Resource did load. But it accesses uninitialized malloc memory. So who's uninitialized at this point? Is it resource? What are you? You're a ref putter. You're not uninitialized. Well, we know that it was the code right after ensure decoder. Here, because we see that it's calling ensure decoder, and then when it returns, it wait, what is this? Is it mov into edx? So it's a read from this address. So it reads from the decoder that we got from the resource. Why would any of these things be null, I wonder? So does it say this? Encoded data looks tasty? It looks tasty, yes. Okay. So let's see. M image decoder. We're just gonna do it this way. Resource. So we'll do ensure coder like that. It's not quite clear to me why this would be troublesome, because we should never have a null decoder, but blah blah blah, everything crashing. Okay, so resource ensure decoder gives us the uninitialized memory. That's good to know. So resource is this. Ensure decoder. Why does this happen, I wonder? M decoder is, let's see what it is before we do anything with it. Printf debug everything. I mean, this is not even really related to the iframe thing. I'm just wondering what the heck's going on here. So it's the decoder pointer is DC, 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 which tells us that the resource pointer that we got is like the resource itself seems to have uninitialized memory in it. Now, why is that? Image resource. Could it be? Ooh, could it be that we are assuming something here? That we're assuming something is an image resource, but actually it's not. I bet you, because the CSS background mechanism. So it's I think this is going to be the problem. So here, this is a background. So it's a this image is used for a CSS background image, style image. So image style value, style image style, yeah, image style value. This guy here, he is a resource client, and where's the code that does anything with this? Here, oh, look at this. This code right here loads a generic resource. And then we try to, when we fetch it from cache, we think it's an image, and we cast it to an image resource. So that's no good. So we should just do this, and this will make it an image resource, but it's not really good that this breaks so easily. And then we need to teach this thing how to share the decoded image, but maybe we'll just fix the individual little bug here, and we'll say fix me, use the shared decoder from image resource. Okay, so how do we make sure that this doesn't crash like this? I guess the resource knows what type it is, right? So when we create an image resource client, maybe we should assert that we are expecting that type of thing. So let's see, resource client, let's do something like this. Virtual resource type, client type, expected type. I'm going to say client type, yeah. And here the default thing will just be to say resource type generic. And in the image resource class, we will override this. Image resource client class, rather, sorry. And I think we'll make this a private thingy. Oh, no, wait, hold on, back up. It can't be. We're inheriting from this thing. I keep forgetting. But this can be private, because we only need this in set resource here. So when we set a new resource on a resource client, then what we'll do is assert that the resource client, the resource type, is our client type. Yes, that'll be good. And here we'll say type const return m type. And then if I don't have that fix in the image style value, so if this is still generic, oops, let's just make sure that we get that assertion. I love assertions. It's such a good way to protect your future self from the laziness of your current self. because like you can assert all these situations that shouldn't happen, and then your future self will have way less debugging to do, because instead of like cascading into this weird domino of failure, you'll just assert sooner, which narrows down the the scope of what your future self has to debug. So that's why I love assertions. All right, yeah, so now we're getting that assertion failure. That's really good. And then if we fix the bug, set the right resource type here, then it still fails. Okay, well maybe that's a good thing. So why is it still failing? Set resource, load resource, type. Wait, why does that fail now? I mean, it's a good thing that it's failing, but why? Type generic. Who else loads generic? Type. Wait, did I just mess up the virtual? No, I didn't. Image resource client is. But did I make the style value the right type of client? No, I didn't. He also needs to be an image resource client. Okay. That's why it was not working. So if we're consistent with our things, then things will work better. It's a nice little project for a Friday night. I think we're gonna tie this together and write some nice commit messages, and then maybe that'll be it for today. But oops, that's not how we do that anymore. Click, here we are. So cool. All right. So let's start with the style or the resource client fix that we just did. So these guys and these guys. And did I forget something now? This is a whole bunch of hoo-ha. So you go away. But everything else is basically useful stuff. And do we have a bunch of irritating debug here? Yes, we do. Look at that unpleasant debug stuff. We shouldn't have that. Oh, did I not do that right? Git reset. Cached. And this is looking pretty good. Okay. Midweb. Fix mismatching resource subclass types. This was a confusing but image style value loaded its image resource as a generic, while HTML image element loaded as image. We now assert this patch fixes the issue and adds an assertion when to verify that resources that we only share resources have the same CFS class. Yeah, actually, maybe we should go in the loader as well, and when we grab something out of the cache here, we should say if it value is not, if it value type is not type, not using cached resource for request.arrow, since there is a type mismatch. This is basically a fix me, I think, because we should maybe have a fallback path or something where we still don't actually load from the network, but we figure out some other way to share it. Because like there could be some scenario where you would want to do I don't know why, but you would want to do like a generic load for something that you already have cached as an image. Let's see, git add liblab assert that we don't reuse cached resources with wrong type. Okay. Oh, so many fixes stacked on top here, but it's all good. I still like this very, very much. So we'll add this. It's all together now, I think. So libraries, liblab, and these boys as well. And commit-a. Web. Start adding support for the iframe element. Okay, this patch introduces a bunch of things. Subframes. Web frame. Create subframe. iframe element contains a hosted web frame. Wait, let's say owns the hosted web frame, yes. Loads and owns the hosted web frame layout frame. Layout and rendering of hosted frame. There's still a huge number of things missing, like scrolling, overflow handling, event handling, scripting, etc. But we can make a little iframe in a document, and it actually renders another document there. I think that's pretty cool. Yeah, I do think that's pretty cool. And there's a lot of stuff. We didn't even talk about the security stuff, but all of that we'll have to dig into that when we start adding scripting of frames, because we don't want you to, you know, make an iframe and load my local files, and then check what's in my local files and stuff like that, and all these other things. But one little step at a time. And this is where we'll end it today, because I am pretty tired, so gotta clock out. But if you made it this far, then I thank you for watching. and for hanging out. And I do hope that you saw something interesting. I certainly think this is all very interesting, as you probably know. And I guess I'll see you next time.